Hey guys, and welcome to one more episode of Builder Nation. For today's agenda, we have Dr. Henrik Christensen with us. He's the director of the Contextual Robotics Institute at UC San Diego and a well-known expert and a national policy leader for the field of robotics. So thank you so much, Doctor, for being here and joining us this morning.
Hey, thank you for having me. This is going to be fun.
This is going to be fun, indeed. And before we start with this interview, why don't we let our main guest introduce himself? Welcome, Doctor. If you can share a little bit about you, about your experience, about your past years, it will be amazing.
Sure. As was mentioned, I'm the director of robotics at UC San Diego. I'm sort of known as somebody that moves every 10 years. So born and raised in Denmark a long time ago, was there for 10 years. Then I moved to Sweden and started a new research center there on autonomous systems. After 10 years in Sweden, I thought, it's a cold, dark place. Let me try and go somewhere else. So then I went to Atlanta and was there for 10 years to build up a new research center on robotics and intelligent machines. And then finally, 5 years ago, I came to San Diego. It's always sunny in San Diego. We complain when it's overcast. It's bad weather when it's overcast. So now I'm here. So through this, done a lot of work in robotics. I was on the team that developed the first robotics vacuum cleaner. I've worked on sort of autonomous driving cars. I've worked on with KUKA on doing industrial robotics. A very broad experience of building robotic systems.
Really interesting. I'm glad that you're enjoying San Diego, the warm weather, just like here in Mexico. And how did you first start? Like, what was your first approach in robotics?
So my first robotics experience in robotics, actually my background was in computer vision. So, I was using cameras and then I'm like, what's the fun of using a camera if I can't move it around? So basically said it would be much more interesting if I can put this camera on a robot, I can drive around and figure out what's going on in the world. So we got a small robot, put cameras on it, drove it around. And that way I can sort of close the loop. I can understand what is in the world with a camera. Based on this, I can sort of build the equivalent of what we have, an internal model of what the world looks like. And then I can start interacting with it. So that was, for instance, what we did for the first vacuum cleaner. How can I build sort of a simple model of what the world looks like, and then use this to figure out how do I come up with an efficient strategy for cleaning the world.
And when were you doing this work?
This was about 30 years ago. So when I started, we were using really crappy cameras. It was a lot of sort of broadcast cameras that were being used, and we had to sort of rely on, and we could only get images that were so big. And then over those 30 years, we've seen progress mainly driven forward by cell phone technology and sort of consumer electronics. So based on this, today I can sort of, in my cell phone, I can do processing that is at least 1,000 times more efficient than what we could do 30 years ago. So today we have much more computing power, we have much better cameras, we can do it in a much smaller footprint, so this is sort of a small embedded computer that you can easily get today. I have 3 cameras on it. It can do up to 8 cameras. It has more processing power than my laptop, and it's less than $1,000. So back then, a robot was really expensive. It was, tens of thousands of dollars. Today, it's not very much.
And about the experience that you had at the beginning, how hard it was for you to start? Did you build up a team? Was it by yourself at the beginning? How was this process when you were first starting?
Well, so when we were first starting, I started myself, but then I very quickly sort of built a team. So I had a team that was, some were doing sort of the mechanical engineering, some were doing the controls, and some were doing the perception, where we were building sort of a model of what the world looks like. But I think the main thing was it was really expensive. So today, in comparison, I have a class here at UC San Diego where I introduce a sort of introduction to robotics. And we basically give every student a small robot. And then 2 weeks later, we said, now you have 2 weeks to make it move. And then then they will make it move. It will not be very good. They're very frustrated. They're like, oh, this robotics, it sucks, it's hard. And then I teach them about feedback control. And suddenly they're like, thank you. Now I got feedback control. So 2 weeks later, they have to drive it around and actually do it reasonably well. And then 2 weeks later, they have to build a system that automatically maps out the environment. And then 2 weeks later, they have to come up with a strategy. If I tell them go through a maze, then they can navigate through a maze. 2 weeks later, so at the capstone of the course, they have to implement all of this, bring it together, and implement the functionality that corresponds to a Roomba. So if you look at it, in 10 weeks, they went from never having heard about robotics to having built the equivalent of a Roomba. So we've seen so much progress because everybody can get it. Everybody can get it access. It's a cheap robot that we're using. We're using sort of an NVIDIA Nano with small robots called JetBot. But now we're also trying to do this with a Qualcomm system. So there's lots of these out there that are somewhere between $100 and $200, so everybody can afford it. And within 10 weeks, they can build the functionality that corresponds to a Roomba. I think that's super cool. When I started, it was expensive. It was tens of thousands of dollars. It took, months before we got anything moving. So we've really seen sort of a compression of how much functionality can you get to in very little time. And I think that's sort of very inspiring in robotics today, that we can do so many things. I have people now that are flying drones for doing sort of environmental inspection to see if we can find forest fires. You give them a drone, it's still a few $100s. You give them simple programming tools, and very quickly they can actually contribute to building new intelligent systems. I think that's incredibly inspiring.
It is indeed. And I can tell you from someone outside of the industry, which is someone like me, a mortal, I will never thought that robotics will be affordable. And nowadays, now that we're talking about today's world, I think that with all the information that we have, people might think or might see robotics like a Hollywood movie, science fiction, maybe something not as real or something as close. How will you turn it around?
So I think people have very different sort of views of where robotics is going. And of course, Hollywood is very good at sort of creating the dream. So one of the things that I do is that I also edit the US National Robotics Roadmap, where we sort of point to where do we think robotics is 5, 10, 15 years down the road? What are the opportunities there? And we look at what can we do in manufacturing. So one of the things we're saying is that using manufacturing, we can bring production much closer to the customer. So we're using it for manufacturing cars. We're using it for next generation cell phones. All of this, and there one of the challenges is that we all want highly customized products. So and because of this, we have to use automation. So standard sort of car that you can buy, you can go to the dealership and buy today is available in 4 million different configurations. So because everybody wants a different audio system, different seats, different interior decoration, all of this makes it really hard to sort of go and say, no, we only have one. And to provide this to the customers, we have to do a lot of automation so that we can guarantee this. Same time, manufacturing is becoming very lean. And at the same time, it's actually helping people do what we call dirty, dull, and dangerous. So you don't want to do sort of repetitive jobs all the time because it will ruin your shoulders and your elbows. That way, the robots are doing the dumb stuff and the people are actually doing the smart stuff. The other area where we're seeing this is, of course, in services. So logistics, we see, during COVID, we all stayed home for a long time. And now, we're getting sort of home deliveries. Don't have to go to the grocery store anymore. You put it in through whatever your favorite e-commerce app is, and you get it delivered to your house. We are now starting to see robots that are doing these deliveries. But also we're seeing, for instance, in emergency services. So here in San Diego, if you call 911, the first thing that happens is that a drone will take off from the emergency center, and it will fly to where that phone was calling from, and it will provide downward imagery, and it will tell you Do we need one ambulance? Do we need two ambulances? Do we need a police cruiser? Do we need a tow truck? All of this happens so that very quickly you can provide an appropriate response. So this is done with robotics technology that are giving first responders much better awareness of what's happening. A third area where we're seeing this is in helping people in their homes. So we're starting to see, so we have a Roomba at home that cleans, and it's that simple. It's automatically programmed. It's the latest that automatically goes and empties itself. I don't have to do anything. It just cleans my house. But also we're seeing lots of elderly people that might be becoming sort of mobility impaired. It's hard for them to go to the kitchen and pick up stuff. Now we're starting to see robots that can actually go and you can go to the kitchen, prepare a meal, put it on a tray, put it on the robot and say, could you go to the dining room with this? And then you slowly get to the dining room. And when you get to the dining room, there's a tray there waiting for you that you can put on this. And this is technology that we can deliver today for less than $1,000. So if you look at it, and at the same time, it can drive around. Amazon just came out with a new robot, Astro, that can do the same thing. So my mother still lives in Denmark, and I call her once a week. If she doesn't answer, I'm like, is she okay? Now imagine I can have a robot that I can drive around in the home and say, oh yeah, she's sitting there, she's just sleeping right now. That would already make me much less concerned. So opening up for this, where you can get access for people that are mobility impaired, or she can say, we can have a Skype call, but the camera comes to her. She doesn't have to get to the camera. So there's a lot of these where people are starting to feel isolated, they're mobility impaired. With robotics technology, we can open up for this. The other area where we're looking at it is, of course, in medical robotics, where you can do surgeries, you can do sort of rehabilitation. So today, for a lot of things like a knee replacement, a hip replacement, but even if you have to replace a heart valve, today what we can do is that we can go in between the ribs. We don't have to crack the ribs to actually access the heart. So I can go to a surgeon, have my heart valve replaced in the morning, and they will release me from the hospital in the afternoon. You don't have to stay in the hospital for a full day for major surgery like a heart valve replacement. So this is getting super cool, that we're getting to a point where this is really changing people's lives, and especially during COVID, where people just not want to be in the hospital. They would like to get out again. And of course, we're seeing autonomous driving cars as another technology, where we're getting to, I have a really nice car, but I did sort of the calculation of what is the cost of having a car. And I use it 1 to 2% of the time. So if I look at it, it's a lousy investment. It would be much cheaper for me to drive an Uber all the time. And slowly we're getting to where we have autonomous driving cars driving around. So here on the UCSD campus, we have 2 golf carts that do autonomous mail delivery. So they drive around, and I still have a driver in there because we want to get some experience from it. But largely, we don't need to have people in the car anymore. This will be convenient for teenage children to be able to go to and from the theater. You don't have to drive them. It'll be convenient for elderly people that are getting sort of mobility impaired, or their sight might not be as good. We can still drive them. So this is technology that's moving very rapidly to get to a place. So all the places in your daily life, manufacturing, getting to and from work, getting cleaning in your home, assisting your parents, and even doing sort of first responders, is all going to use robotics technology. So I think that's super exciting.
I think that this is maybe a hard question, but do you have like an estimated year that maybe we can apply all of these improvements? Maybe like 2050 or something like that?
I think that's too far away. I think it'll be before that. So normally what I would say, sort of for autonomous driving cars, kids born today will never have to drive a car.
Oh my God, my kids will not have to drive then?
No, they don't have to drive. So less than 15 years from now, but it's going to take us some time. We're still not quite there. But we are seeing, so right now we're seeing autonomous driving trucks on the interstate. There's no driver in the driver cabin. Driving from Arizona, from Tucson, Arizona to San Antonio in Texas, no driver in the driving cabin. That's happening today. So we will start, and we're seeing experiments being done in San Francisco about driverless taxis. Waymo has been testing their sort of slow-moving vehicles for the last few years. So this is happening for robotic surgery. This is happening now. We just did some experiments here where you combine augmented reality with robotic surgery. So we're doing this with the Navy. So imagine there's an accident, somebody breaks a leg on an aircraft carrier, and it's complicated. And you don't have the best surgeon on an aircraft carrier, but you can't have all of them there. So what they can do is they can call us, and one of our best surgeons for Center for the Future of Surgery will take on his AR goggles, teletransport himself to the surgery, work with the surgeon on board the aircraft carrier and say, oh, wait a minute, there's a bone here. You need to be very careful about this. There's a nerve here. We need to be very careful with. So now you can do consultations anywhere in the world using augmented reality and provide the best medical care no matter where you are in the world. So this is happening today. This is going to happen. I mentioned to you, we're doing the drones for doing first responders in Chula Vista. Today, we have drones that fly out and fly over the fire, provide a detailed map of where the fire is and how it's moving, so that we can tell the firefighters and say, this is, there's a hole in your firewall right now where the fire is getting out. You need to get some first responders there. So this is all happening today. And of course, I have my vacuum cleaner at home. I have my Astro from Amazon that drives around and can do things. So I think there's two questions of how do we make it more accessible to people, both in terms of making it simpler to use, and the other one is how do we make it cheaper? And then the other one is also how do we slowly get it into everyday life, and so it becomes a natural part of this. But it's going to happen. Some of it is here today. Some of it is sort of within the next 5 years, the low-hanging fruits. And then 10 to 15 years out, you will not have to drive a car. You can get into the car and say, take me to dinner, and it will take you to dinner. And the advantage is you don't have to worry about parking. You get out of the car and say, pick me up again at 10, and it drives away and it comes back at 10.
It sounds super exciting. I mean, Doctor, I wish I could be your your student in my day-to-day. I think that robotics has so much to offer that maybe normal people will never think of, like the future reality and how it can help us in our everyday life. And do you feel like there's a huge difference, that will be the question, in between robotics in US and in Europe?
No, in the US and Europe, it's largely the same. So it's very similar. There's some restrictions, like in Europe, there's a lot more focus, for instance, on privacy. So it's so you have to be very careful about what information are you storing on your robot. If you're driving around in the environment, you can't just use cameras because you could sort of be detecting people, and because of this, you have to guarantee that you do anonymization. So Europe is very careful about what data do you have access to, how you're using it, and how you're storing it, much more than the US. But other than that, if you look at, for instance, the big industrial companies, ABB, KUKA from Europe, Yaskawa and others are in Asia, Fanuc is in Asia. So we have much less industrial robotics manufacturing taking place here. But for instance, if you look in Denmark, where I'm from, in the city Odense, where Hans Christian Andersen was born, they have a robotics cluster today with more than 300 robotics companies. So they are sort of considered the Silicon Valley of Europe for doing robotics development. We have a big area around Munich. So you're seeing Europe focusing, but more focusing on other applications. So they did collaborative robots before we did it in the US. They're doing sort of interesting things in construction. They're building, how could we use robots, for instance, for doing shipbuilding, they're building windmills in Europe. So you're seeing slightly different areas, but Europe is doing really well. And at the same time, the big area where we're seeing growth now is in China. So China is experiencing somewhere between 30 and 50% annual growth in robotics. It's in shipbuilding, it's in automotive manufacturing, but also slowly it's getting to healthcare, but also it's getting to areas that we might not have thought about. So like in China right now, you can buy a robot that for a child that becomes the child's companion. So in Asia in general, there's a lot of effort on making sure that you should not give your children money. You should give them an education, because then they can make their own money. So often children in Asia will go to school. At the end of school, they have a mentor at home that will work with them for another 4 or 5 hours. And often, the children are like, really? I have to go to school again? What if you could build, and what has happened is that you can build a robot that becomes the companion, so that it's helping you do your homework, it's helping you teach this, but at the same time, it's sort of like a game. So imagine, a child is saying, I don't really like math. It's not that much fun. I would much rather dance. And then we play a game and said, why don't we solve these 3 math equations? Once we've done this, then we'll dance for 5 minutes. So now you've incentivized the kid to solve the math problem, because then they can do dancing. And the better you do at math, the more time you do for dancing and singing. So every child, you start understanding, what are your preferences? Do you like math? Do you like sort of social sciences or those things? And then based on this, we design a curricular where all the time we incentivize you to actually do better and better. There are robots like that in China today. So they have a big focus on education, on training, because it's really important. In the US, we don't have the same sort of focus on how do we incentivize our kids to study more than they've done before. So we're seeing around the world different priorities, but all of them are making tremendous amounts of progress.
That's great, talking about, different countries and how you can see the new researches and the new developments. I noticed that there's like a National Robotics Special Week where you can find out about new developments in the industry.
So we started doing the National Robotics Roadmap 2009. And then I was presenting it to Congress, and Congress said, how can I help? And, most cases Congress can. And said, well, it would actually be good if there was sort of more focus on robotics and what can we do? And they said, well, let's write a law that says that the second week of April every year is National Robotics Week. So every year, second week is National Robotics Week. And then actually iRobot, the creators of the Roomba, helped us bring together and say we should provide a lot of information about what are the events that's going on locally for this to sort of promote robotics. So iRobot has been really instrumental in bringing this together. There is a nationalroboticsweek.org where you can go and you can see sort of a map of what is going on in your neighborhood. And in many cases, the universities, the local high schools are opening up their doors. Robotics companies are opening up their doors and doing sort of promotion, talking about what is robotics. So in many cases, you will have open houses across the nation. I think last year we had more than 340 events going on in all the states across the nation. So you can go to this and find out, is there a local high school in my area, or is there a local university where I can go and see what's going on? And that's super cool, because it's a way of sort of creating awareness. And it's also, as we mentioned earlier on, in Hollywood, you have sort of this picture of, it's the robots, they're taking over, they're dangerous, I couldn't trust them. Going to these local events enables you to sort of see what is going on, what are real world robots. So it's a way of trying to create more awareness of STEM, so science, technology, engineering, and math, but it's also a way of figuring out what can I do in my local neighborhood. So as an example, we also have the first robotics competition, so the Foundation for Increased Recognition of Science and Technology, where high school kids and all sort of K-12 kids can go and do robotics. And I think this is a way for them to go and learn about that math and science can be very practical. It can be used for environmental cleanup, it can be used for the vacuum cleaner, it can be used to assist to people. So it's really a way of breaking down the barrier and saying robotics is not only something fancy that unless you have a college degree, you can't participate.
Really, really down to earth, I will say. And I noticed that Georgia Tech has like this, I don't know how to call it, but it's like an institute for robotics where students can develop their own projects. I noticed that they develop a robotic guitar or something like that, that they can play the guitar for you automatically. How many classes do they need to take in order to develop these projects, or are they by their own? Or
So you can get started with sort of relatively little effort. So one of my colleagues here at UC San Diego, Sarah Nadiri, has developed sort of a curricula where you can basically start, and within 2-3 hours you can do simple, let's say, you can build a small robot that can play a song or something like that, and then you can build a guitar, or you can build sort of a small robot that moves around, and so with within a day you can actually get started. You can do something, you can see the result of it, because otherwise if it's sort of like 3 weeks from now you'll see something move, people are like, this is too boring. So we're trying to develop it so it's incremental. You get something started very quickly, you get to a point where it's actually useful, and then at the same time we're not trying to be prescriptive. We're trying to sort of say, we want to give you a set of tools. How do you interface to a computer? And it can be something really simple, like and Arduino, sort of a very simple sort of board like this that is sort of $12 on Amazon, and you can use it to do very simple programming, get started, and then we want them to use their imagination to say, how could this help you? Do you want to build a robotic doll? Do you want to build a music instrument? Do you want to build so imagine you as a simple thing. One of my good friends, Gil Weinberg at Georgia Tech, built a robot that will basically tap to the music. So imagine that we're listening to a song, and then it will start sort of, and that's a simple robot that are just sort of tapping its foot to the music. That's pretty cool. And you now learned about music perception, you learned about robots, and you could do it for a few dollars. So are you interested in music? Are you interested in dance? Do you want to build a rocket engine? Whatever you want to do, we should enable it.
Oh, that's so encouraging. I'm kind of regretting studying communications and digital media and not getting into engineering school. It's never too late.
No.
And I've been recently talking to other founders in the industry, and whenever we're in this conversation of like their companies and how it's their process and how to develop like new projects, they've been telling me that they have find out, or they have faced different challenges when it comes to the procurement process. Are you by any chance close with this process at your companies?
So I think in general right now we are seeing sort of the supply chain problems that are sort of impacting everybody, which is sad, because there's such a big demand. The economy is growing, we're seeing all of this, and at the same time we're sort of being slowed down by supply chain logistics. But at the same time, it's also an opportunity. So we're seeing this where we can use this to, how can we help bring in more automation to help solve some of these challenges? How can we do faster unloading? How can we do faster loading? How can I do deliveries to you faster? So I think, yes, we're seeing supply chain challenges right now, but we're also seeing it as an opportunity. Let's figure out how can we solve this long term, so that the next time we get a pandemic or something like that, then we will be more robust. We'll have built a system where we have better analytics. We understand where the bottlenecks are, and then we can use this. So yes, we are seeing challenges of how we can build, but I don't want to know. I'm not interested in solving, and certainly as an academic, I'm not interested in solving a problem for the next month. I'm interested in solving a problem that will give me growth for the next 3-4 years.
And talking about challenges, can you tell me the biggest challenge you have faced when it comes to manufacturing?
Well, so I think the biggest challenge with manufacturing is always that traditionally it's manufacturing is, for most of manufacturing, it's hard and it's slow. So the best example I had is when we built sort of the first autonomous vacuum cleaner. and it had 7 microphones on board that were basically sort of listening to what's going on in the environment. And then I came up with a solution where I needed an 8th microphone. And then I said, if we got an 8th microphone, this would be really fantastic. And the engineer said, no, the model has already gone to production. There's no way we're going to add an 8th hole to the chassis for this. So sometimes it's very hard for, especially for me as a software engineer, to understand how long the process is and how slow the process is. And that's why we're seeing when we do, for instance, cars, you only do major changes to cars every 4 years. But at the same time, if I look at it, in 4 years, our computing processes will have tripled, or it will have 8 doubled. So we always have an order of magnitude more computing power. So it's hard for me to have patience and say, well, you can get it in 3 years from now. I'm going, no, I want it on Monday. So we have sort of this schism between how fast can we develop software, how fast can we develop this. And in terms of manufacturing, it's just been hard because right now it's such a slow process.
But that's a cool thing about robotics, right? That it's the best of both worlds, if I can put it like that. I mean, you have software and you have hardware. And how many people do you need in order to, let's say, build a vacuum cleaner? Like how many software engineers, how many hardware engineers?
Well, so it was, back then it was sort of a team of about 25 people that were doing this. But I think it's, there's a lot, we see lots of startups today that are 3-4 people. Also because compared to sort of 25 years ago, there's so many things we can do manufacturing as a service, where, back then you had to do everything, you had to sort of do it yourself. Now I can call up somebody in Taiwan or Shenzhen and said, I need a device that sort of looks like this, but I need 5 other features. Tomorrow I can get it delivered. And so the fact that you can outsource, and I can outsource to somebody said, could you do a nice industrial design for me? Can you do, the electronics sort of on this? Can you do that makes it possible. So in some sense, as a startup, you are becoming a senior manager for a group of companies that do highly specialized services. So you don't need to do everything in-house anymore. And I think that's encouraging. So one of my former students is right now building sort of a super smart camera for being able to inspect bridges and all of this. And they only need to be 3 people because the rest of it you can outsource. So of course, then you want to know, how can I now sell it? Should I? And there again, you can do, if you look at it, Amazon, all of these sort of large e-commerce companies can do the sales. So you don't have to have a big sales force. You can outsource it to the e-commerce sites and they do the sales force. They will take 20 or 30% cut on top of it. But the advantage is it will get you started. You don't have to build up a huge organization with 50 people before you can sort of do your first sale. And I think that makes it, in terms of entrepreneurship, it makes it much better. I think the other thing that's happening is that we're getting, by now, there are lots of incubators. So lots of incubators where you can go, you get trained, whether it's called iCore or other programs that will train you on how do you do entrepreneurship. Through this, you get access to people that have established networks. You get access to people that have money. You get access to sort of what is the process of doing this. So I think 25 years ago, we had to do all of this. We had to form a company. It was a lot of effort. Now you can, with very little effort, get started and do something. So to me, that's very encouraging.
That is indeed. I mean, nowadays it's easier to get outside, like you're saying. We have social media. I don't know, you can do a LinkedIn post or Twitter post and say, hey guys, this is my project. Boom, it gets viral. Boom, you get investors. Yep. Boom, you get your project out there. So
no, just saying, people. So you were saying before, well, I did media rather than engineering. Now, you can go and hire media specialists that put it up on social media, in all the right media, to make sure that you get it out there. You don't necessarily have to have it in-house. So you don't have to have a full-time media manager. You don't need a full-time social media manager. You don't need all of that, because you can largely outsource this. And that makes it, so, even 10 years ago, that was almost impossible.
Any last advice that you can give to young engineers, young entrepreneurs, young people who are interested in robotics?
the first advice would be go for it. There's so many opportunities right now. There's so many tools available, and also, we can do, if you're interested in mechanical engineering, we can do 3D printing, so we can do rapid prototyping. We can use CAD tools to very rapidly go from design all the way through analysis. So you can do SolidWorks or any of these to very rapidly do this. If you want to do programming, there's so many tools out there. There's so many good tutorials that it's getting started is very manageable. And then I said, build a network, build, know people in social media, know people in figure out how can you focus on what you think you're good at and outsource the rest to build sort of a network. So and through this, I think it's possible to get started and then figure out locally, where are my local incubators? Where can I find an I-Corps program, or what can I find that would sort of help you get started? So it's important not to sort of say, oh, I don't know, how would I do this? There's somebody locally with that expertise that can help you make it happen. So I'm sort of saying, go for it full speed, and there's always good people out there that are willing to help.
Okay, well, thank you so much, Dr. Henrik, for being here and for sharing all of your amazing knowledge with us. We were super lucky to have you. Do you have any social handles or any social media handles that we can find you?
Sure, you can always find me. So on Twitter, I'm HISKOV. And you can also find me on LinkedIn. If you just type in my name, I will come up easily. So it's always, and I'm terrible at answering my phone. I'm pretty good at email. So it's, calling me is a lost cause. But I'm pretty good at sort of answering social media posts if people have sort of comments or questions.
Thank you so much. And yeah, I agree. You're super quick at answering emails. Thank you so much, Doctor.
Sure.
And remember, guys, that you can also find more information, interesting articles, interesting interviews on our website, controlhub.com/builder-nation. Thank you so much, Doctor. It was my pleasure.
Thank you. Thank you for having me. Have a great day.